So welcome to this SEFI at Work session. This particular session has been organised by the Curriculum Development Special Interest Group of SEFI, and we're delighted to have everyone joining us, and a group of colleagues from across the world to talk a little bit about their integrated programmes and look at integrated programs and form of integration as a part of curriculum design. My name's John Mitchell. I'm from University College London, and I'm one of the co-chairs of the Curriculum Development SIG. Unfortunately, my colleague Emmanuel Attili is not too well, and so I'll be deputising for her on some of the bits about the IEP and UCL's integrated programme. Just to say, this session will be recorded, so if you do not want to appear, please keep your camera off. Please use the Q&A function for any questions, and we'll get to questions later on. And also, as per SEFI policy, we don't allow AI chatbots, so please remove them. And yeah, if you can keep your microphones off, that would be beneficial. So welcome. And without further ado, I'll hand over to colleagues Becky Bates from Minnesota State University, Susan Lord of the University of San Diego, and Jenna Carpenter of Campbell University.
Thank you. We are very happy to be here, and especially happy that the time zones would work out, because we basically have all of the United States time zones except Mountain represented here, and we're happy to spend this first day of December partly with you all. So we've been working together to think about what integrated engineering is and what it looks like. And while we have very different programs, there are some commonalities that we think are really valuable and are things that we see happening in other curricular spaces. So when we talk about integrated engineering, we really stress the importance of the context. And so we also like to think about using stories to talk about this. So when we think about what integrated engineering is, sometimes that might be crossing technical disciplines. For a lot of us, it's merging professional skills in a technical context. But overall, we're really aiming for holistic education that thinks of a student as an entire person, as an entire learner. And that also includes that philosophy for faculty, that we are bringing our whole selves to this, and that our lives in some ways are integrated as we think about integrated engineering. So the stories for today are really going to be about how we integrate these ideas in curriculum. A lot of times people wonder, what is integrated engineering? And we feel that this is a working definition, a changing idea of what integrated engineering could be. And what we're providing today are 4 examples of what it could be. And specifically, though, we really think that, as we have here, that we are taking an approach that allows us to expand our idea of what engineering could be, so that it is more inclusive, so that engineering becomes something that draws people into being able to use their entire selves and their entire concepts of the world as part of how we do engineering in this world. So Susan, I'm going to turn it over to you to set up the stories.
Okay, thank you. So as we think about what this might look like, and I think we want to be really clear here that we don't have the set in stone definition of integrated engineering. It's more of a mindset, a way of approaching. All of us integrate some different things. And one of the points of this slide is to show that it can be done in many different ways at many different places. We're hoping it might spur you to think about how might this apply in my context. And so our settings are all different. University College London, UCL, is in metropolitan London. I'm at the University of San Diego, so I'm on an international border between the United States and Mexico in San Diego. We're a private school. We're actually a Catholic school, and we're fairly small. At Becky School, Minnesota State University Mankato, they're considered outstate. I might say rural, but in Mankato, a smaller town than say San Diego or London. They also have off-campus sites, and it is a public school, the way public is defined within the United States. Campbell in North Carolina is a rural, metro adjacent. If you're familiar with Raleigh, North Carolina, they're not too far from there. They're a private institution and also faith-based. So we cover a big range here of different kinds of schools. At the top, those numbers next to it are the year that the first graduates occurred, and the next number is approximately the number of graduates each year. So at UCL, the first graduates that had this integrated engineering program were in 2018, and they have about 1,000 graduates. These are undergraduate students each year. At my university, our first graduates were in 2019. We have about 15 students every year that graduate in integrated engineering. Becky School, first graduates for 2011, so she's the most senior of the lot of us here, with 75 students a year. Campbell, 2020, so the most recent, but not that much different than mine, with 35 students a year. Then the mode in which we think about the integration is also different. At UCL, it's a teaching framework, so an approach to how they do, particularly what happens at the beginning of the curriculum, where all students are involved in something where they're integrating across different engineering disciplines, but then they would choose a discipline to major in. At my university, students would major in integrated engineering. I'll talk a little more about this later, but my degree is a unique BS BA. The BA is usually what students would get in a liberal arts discipline. My students take the same liberal arts as everyone else on campus, and so they have this degree that is a combined holistic degree. At Minnesota State University and Campbell, the degree is a Bachelor of Science in Engineering, a more typical degree for the US. The structure of it is different in terms of how is it organized. At UCL, it's faculty-based, so there are folks who identify as being in the integrated engineering program, like Emanuela, or in his previous life, John, not at his current life, I don't think. And it goes cross departments. And so there would be different folks who would come from different disciplines, but would be working on this integrated engineering program. At my university, it is also true that we all come over this in my department, have different backgrounds. I have a PhD in electrical engineering. I have a colleague with a PhD in civil, another with mechanical, another in material science, another in biomedical, and we all form the integrated engineering department. But that is our academic home, is within this specific department. For Becky at Minnesota State, it's also department. So again, her faculty come from a number of different, more traditional disciplines as far as their academic preparation, but now they're in this department figuring out how to provide a curriculum for their students. Theirs is interesting, and I'm sure she'll talk more about it, in that it focuses on the upper 2 years. In the United States, typically college is 4 years. And so the students, most of her students go to a different campus for the first 2 years, and then would come to her campus for the last 2 years, where they do project-based things above just the course level. Mine tends to be more typical courses. At Campbell, they're a school of engineering where they don't have specific departments. They're the newest founded engineering program overall, and they chose to have a whole engineering school, of which Jenna is the dean, rather than departments, but then students would choose a concentration. So I'll go back the other direction. So at Campbell, the students might identify as mechanical or chemical, electrical, or systems, but that would be because it is their concentration. All of them, I believe, get an engineering degree with an opportunity to focus on this concentration. So the goal is to have them see lots of different parts of what engineering could be. At both my school and Becky's school, our students do identify as integrated engineers, and they really have a pride in that. We have a society for integrated engineering because there is no IEEE or something like that for ASME or no large professional society for integrated engineering. But our students still need an opportunity to build community and to help more younger students to understand what this might be so that they can decide if they want to major in it. So we now have a pretty good student group that is good about getting pizza so we can all meet for lunch and have different speakers and things. At UCL, it is different, that the students would really think of themselves as a UCL engineer. And they would have a disciplinary major, but they might have an IEP, the Integrated Engineering Program minor. So they might call themselves an aerospace engineer, but then they might have a minor, which I hope John might talk about, they would identify as part of their identity. So there's a big range then of what we all think of ourselves as doing integrated engineering, but it looks very different at the different institutions. So next, what we'd like to do is to talk about each of these in a little more detail. I've given you a big overview, and I do encourage you to be putting questions in the Q&A, I guess it is. And I don't know if someone is also monitoring the chat if we're able to look at that, but we do encourage questions because we know that these things may look very different. Some of your questions may be answered as we go through each of our programs in detail, but we're hoping that we can help you see what this might look like. And certainly it is contextual, it's very context dependent. So what works at one of our schools might not work at yours, but there may be pieces of what each of us are doing that might be helpful for you. So with that, I will turn it over to John.
And I'm going to interrupt just to quickly say we're going to give you a little bit of time to come up with questions, and we will be spending probably the last half of this responding to Q&A. All right, go ahead, John.
Thank you. So as Susan mentioned, the IEP we now think of as a framework, and it really is a way of piecing together the different strands of the curriculum. And this really came about because, we were a university of a number of departments, all running their own programs at the same time. And this was something that was developed, an idea and a desire of our dean to try and connect across those departments and demonstrate to students how their disciplinary identity could feed into the sort of interdisciplinary projects and challenges that we felt were central to the developing engineers that could deal with the future world challenges. So the IEP really looked to change some of the key elements of the curriculum around the thread of mathematics, around the thread of project-based. We call them challenges and scenarios, and you'll see in the right-hand corner the thread of projects that go right the way through. But also, most importantly in that we see that thread of projects is, so we often talk of it as our integrating thread, that the mathematics, the disciplinary knowledge that they develop, but also the professional and design skills that they're learning are coming together through this thread. So we were really trying to look to integrate disciplinary, but also transversal skills and transferable skills as part of the development of the IEP, as well as try and give our students a view of both being a disciplinary expert working with other disciplines, but also taking what we call the IEP minors, which I guess are similar to a minor you might see in a US context, that are interdisciplinary in their nature. If you could move to the next slide, please. This is how it builds. So the grey cylinders in the background, which I guess if you're being uncharitable, you could see were silos of the relative disciplines that back in 2014 were very separate and didn't really do a lot in terms of teaching. We collaborated a lot on research, but not on teaching. Daniel Hastings from IIT called them cylinders of excellence, but that may be over-egging things. So the IEP is really looking at how we collect these disciplines together. So our integration, one of the key parts is at this disciplinary level of bringing together the challenges, a set syllabus of professional skills, although each department interprets that in a slightly different way, a set syllabus of maths, but again with some discipline-specific elements to it, as well as this thread of projects, of scenarios, how to change the world, our major projects. And you'll see in the second and third year, the minors, and if we move to the next slide, this is a collection of very interdisciplinary elements that all students are allowed to choose. And this sets a course of modules across both the second and third year that our students will take. And you can see from sort of titles here, they were really designed to be outside of at least any single discipline and appeal to students from a number of disciplines. So from something adjacent to engineering, such as entrepreneurship or management or responsible innovation, to things like nanotechnology that cross boundaries of electrical engineering, chemical engineering, and other sorts. And so this was another form of integration, of trying to bring the students together from the different departments to operate in these interdisciplinary realms. And that's me done.
Scott. And now to Susan.
Great, thank you. That was perfect, John. So at the University of San Diego, again, we have a department called Integrated Engineering. We do have a nice little video about it because as we made that as a department because we found that other faculty were having trouble explaining what we were to students. And so we thought if we could get 2 minutes of explaining it ourselves, that would be helpful. One of our large learning objectives for the department is that students practice engineering with a critical understanding of how engineers engage with and impact society. And so we also, another way we sometimes phrase that is that we have a socio-technical mindset, that the technical is very important, but we want students to see it in the context of the environmental, economic, and social. So students at our university, I'll explain the curriculum a little more on the next slide, but students do take a bunch of engineering classes. They take these integrated engineering classes, and then they choose a concentration. And these are our concentrations: biomedical engineering, engineering in the law, sustainability, embedded software, and an individual plan of study where they sort of choose their own adventure. And as an example of what some of these classes might look like, we have an engineering and social justice class that is required for all students, where students learn about how their identity is shaped by the world and how the world shapes their identity as an engineer. And also another one called an integrated approach to electrical engineering that I'll describe on the next slide. I do want to point out just on this one that sometimes people say, well, how could you do this with ABET or other accreditation bodies? And I have to say, when ABET came to us, they thought we were awesome. They said we were an excellent exemplar, student-centered, forward-thinking, and an excellent example of how you can do the ABET outcomes that talk about students understanding their designs in the context of social, environmental, economic considerations, that we were sort of doing it for real. So if you could go to the next slide. Next slide. Oops. So I wanted to give you an example of what I mean by, whoops, sorry, back to the previous slide. What I mean by socio-technical, because I think sometimes people aren't sure quite what that means. It sounds like there are a number of you maybe in this room that already are familiar with that. But so, for example, in my circuits class, which I call an integrated approach to electrical engineering, it is typical that in circuits you talk about capacitors, but often what we would do is we talk about the current and voltage relationships of a capacitor. We talk about combining them in series or parallel, and that's about it. If we're lucky, students see a physical capacitor at the back of the lab in a drawer somewhere, and usually that's where it stops in a typical circuits class. We try to go one step further and say, well, these didn't just appear magically at the back of the lab. Where did they come from? Where is the material that is used in them? Where is that mined? And so that brings us to the center of Africa, to the Democratic Republic of the Congo, where materials like tantalum are mined. And those are conflict minerals, which are minerals where they are mined actually contributes to profits that support conflict in that area. I've been doing this for a number of years now, and I have had almost no students that actually knew this before, anything about this. So it has, I think, been a useful thing. And so this allows students to think about the larger context of the little circuits things that they are working on. And when it's done well, when we really tie it to the learning objectives and they see it as relevant to the course, then students say, well, it changes their definition of engineering. So I really like that first quote where it says, we looked at a lot of stuff that wasn't engineering, including the conflict minerals, which I thought was really cool. And that was very clearly engineering, but looking at it from different angles. So I'm hoping that students are reshaping and redefining what the idea of what counts as engineering, and I think you can see it in that quote. I do also like this other one of how could I be 20 years old and have never heard of this? And this is like all of it. The fact that Africa has mineral wealth, the fact that colonization has meant that people in Africa don't benefit from it and we do in the West, and those kinds of things. And the last two quotes I really like from the sense of saying this is real world engineering. This really helped me with my learning and helped me see that this was the real world. So instead of getting pushback from these students about why are we doing this, the great majority of my students say, I think this is real world engineering. Also, if you look at where the DRC is, that little red thing on my map, that is where Wakanda, the country that Black Panther is supposed to take place, occurs. And so we actually do get to talk about Black Panther in my class, which is a total win for a circuits class. But we talk about how the mineral wealth in the real life DRC was people there did not benefit from it because it was exploited by the rest of the world, whereas in Wakanda, they hide it so that they are able to benefit and others are not. And we do look at the conflict mineral strategies of various companies such as Intel, Apple, IBM, and Samsung. So students engage with real responsible mineral strategies that are on the websites and get to see how that works out. Okay, next slide. Then I thought it might be helpful for you to have some context of like, what does it look like at USD for engineering overall? So at USD, we are again in the United States, so we're ABET accredited, which means we have to have a certain number of units of math and science and a certain number of units of engineering. There are 4 engineering departments at my university: integrated, electrical, mechanical, and industrial. So if we look at all of them, everyone takes some disciplinary classes. That's what I called engineering the top thing. If you're in integrated engineering, that's a little less than 10% of the degree, whereas in all the other disciplines, electrical, mechanical, industrial, this would be close to half the degree. And these are classes that are more traditional, such as statics for mechanical, electronics for electrical, or operations research for industrial. And then what I'm calling integrated engineering are things like user-centered design, which all of our students take. So that's why the little bit of the little bit of blue, the little bit of the typical engineering degree that is integrated is this user-centered design class. And then in my students all take an integrated approach to electrical engineering, integrated approach to energy, engineering and social justice, an experimental engineering class, as well as a few others. And then they take concentration classes, and most of them do try to integrate, making students see the context of their concentration in the larger world. Then our students also, because we are at a primarily liberal arts school, we have a core curriculum that every student must take, and this makes up 30 to 40% of their curriculum. And this includes things like ethics, philosophy, oral communication, public speaking, religion, we're a Catholic school, history, and a second language. It's a little different for integrated engineering than typical engineering because we allow more flexibility in my degree. So your concentration has to have enough engineering units to satisfy ABET, but it doesn't have to be way over that. And so some of the courses, if they're relevant to your concentration, say sustainability, you could take environmental justice. That would count both towards the core as well as towards the concentration. And then everyone in all the disciplines at USD take about 22% math science classes. So that gives you a flavor overall of what my curriculum looks like. And I will hand it off to whoever is next.
I am. All right, so at Minnesota State Mankato, we think of integration in quite a few different ways. One is this idea of transfer students. So we see maybe 1% of our students start at the university as first-year students. So if the typical engineering degree in the United States is 4 years, in practice that often extends to 4.5 or 5 years because of starting points. We don't see most of our students until they're actually in their 3rd year. So these are students that basically learn their lower division work. So the first 2 years at a community college. So we integrate that. We integrate strong industry partnerships as a project-based program. We pull projects from industry. And then as much as possible, we try to include student faculty autonomy. So this is where we can give choice. We try to make that possible. So as I said, the lower division coursework years 1 and 2 is typically done at community colleges. These are what we call general education and pre-engineering courses. So for the overall degree, which is 128 credits, 25% of that will be math and science, and that basically comes from the ABET accreditation process. Then we have the general education. So even though math and science is still general education, here we're talking about communication, humanities, and social sciences. That's about 18% of the degree. And then we have lower division preparatory engineering courses for 10% of the degree. Then we get into the upper division. And what we focus on here is an integration of design learning, professional skills, as well as more advanced engineering technical competencies. So that's about 25%, the technical competency, about 25% of the total degree. And we have a 4-semester upper division approach where we have industry-sponsored projects. Students work on these and develop all of these design, technical, and professional skills holistically through projects. And when we talk about integrating the whole student, we also think about where are they coming from? Have they had military service, on the job experience? What hobbies and other skills do they bring? We don't think of them as blank slates. So we have a project-based program that's at Twin Cities Engineering, and then at Iron Range Engineering, we have a work-based approach. So this is using the exact same curriculum, the expectation that students are developing design, professional, and technical skills in context. But now we say, let's do this as a work-based option. So the students will do their first 2 years at typically a community college. And then we have a planned 5-semester experience where the first semester is our academy experience. This is really intense. They do a design project, but they're also working on developing specific skills for being on the job, including finding a job. So they are coached in resumes and interview skills, and their responsibility is to find a job that's an engineering co-op. And then for the next 4 semesters, 2 years, they work in those jobs. It's rare for a student to have the same job experience. We encourage them to work at different companies, to have different roles, to really try to develop a range of experiences and skills that will help them be the kind of engineer they want to be. And they're supported in this. They have evening classes with faculty. They have learning coaches that support them weekly. And they're one of our initial challenges was, how do we really build community for these students? We don't want them to be isolated when they're off working as co-op students. So really working on building community with groups of engineering students. And then they would earn their bachelor's of science in engineering. So the last little bit is, okay, what's going on with these technical competencies? So students have, for that 25% of the degree of advanced technical learning, students will take 1 credit chunks. So there's a core, we call it mechanical, but chemical engineers say most of these things are chemical engineering, but that's things like material science and dynamic systems and thermodynamics. And then we have 6 credits for electrical, so electronics, digital logic, various typical things for electrical engineering. And then we have some we call engineering core, because I'm not going to say that entrepreneurship belongs in a disciplinary silo, but we want all of our students to learn something about entrepreneurial mindset, statistics, programming, engineering, economics. That's in the core. And then we have 16 credits that are technical electives. And as we think about these, this is where a student can earn a focus. So as long as there's 16 credits of engineering electives, they'll finish their degree. But if they focus those in a mechanical system space, they can earn a focus in mechanical or electrical. We've had architectural, biomedical, computer, aerospace, just about any discipline that a student might want. And then they're also expected to get contextualized experience. So either a year working in that focus area as a co-op student, or at least 2 of the 4 projects they would do should be in that area. And I saw a couple of quick questions. The default route is the project-based approach. In that all of our students have that, but right now, because the work-based approach is so popular, the majority of our graduates are doing that and having their project experiences embedded in industry. All right, and I'm going to pass it on to Jenna.
Great, thanks. So at Campbell University, as we said, we do have a Bachelor of Science in Engineering, and there are 4 concentrations. Students must choose a concentration. But in thinking about how we integrate this, there are quite a few things that we've talked about that I'll kind of highlight. So one of the things is our program is project-based, team-based all 4 years. So our students do take 4 full years of engineering, and instead of a bunch of gen ed courses up front and kind of the engineering sort of crammed at the end. And all of our engineering classes are project-based. We have 8 values. I won't rattle those off, but those really define our culture. We sort of started with those, and they're woven into our curriculum in very tangible ways. So the relevance, for example, is reflected in the project-based approach, etc. We also have a lot of competition teams. We have 2 NASA teams that complete building moon rovers for a NASA competition. We have a future city team. We are the only one in the U.S. this year designing plans for electrifying the city of Raleigh in the future. And so again, these teams are interdisciplinary, and you've got students from different concentrations working on these sorts of projects. So it's another way that we sort of integrate students. In addition to the projects in their classes, they're working on these competition team projects. We do have open admissions. That's on purpose. So our goal is to not weed students out, but rather weave them in. So no matter what math background students come into the university with, they can start in engineering. We've got 3 different pathways into our program. And again, our goal is to make sure that we're not using pre-college opportunity as a proxy for ability. And the other thing that we really try to do that underpins everything, we want to make sure that we have a 21st century curriculum. Many times in the U.S., if you're not careful, a lot of the programs don't look a lot different than they did maybe 50 years ago. So again, the project-based approach, the team-based approach really helps us graduate students that are sort of industry ready, and that is sort of our goal with this type of approach. Next slide. Oops. Some other things about our program. So we do have a common core, and I'll talk on the slide after this about a curriculum. You can see that in a little more detail. So we do have a common core that all concentrations take. So this common course is first year, mid-years is senior year. So again, these students in the concentration are taking classes together. And again, because we have this project-based approach, we use what we call a class lab. So lecture and lab, same room, same time, same space. 24 students is all we put in a class. So tables and chairs in the middle, and around them in the same room is all the lab equipment. Each class lab serves about 2 to 4 classes, depending on the types of equipment. And that's what lets us do the projects and the demos and the labs, everything integrated with the lecture, which again, really helps them learn the content and the theory and then apply that. Strong focus on professional development and service. Our students have to get 50 hours first year alone. Professional development and service credit. So we offer lots and lots of that. So those are sort of spines that run outside of classes. We have a lot of student professional engineering organizations. They meet regularly. They host K-12 outreach events and professional development events. So a very robust network of that going on, again, in addition to the classes. Because we're in what's called the Research Triangle of North Carolina, it's sort of like the Silicon Valley of engineering, if you will. A huge number of industries here, so very robust industry connections, a lot of internship and employment and other engagement opportunities. We have students who do co-ops as well, and we really work very hard. We do lots of prep with our students to help them interview and get summer internships. And then people in the chat have mentioned professional licensure. So we actually have a course our seniors can take to prepare for what the professional engineering license, the first exam. And then if they take that first exam, the fundamentals of engineering exam, before they graduate, we pay the fee. So as a result, 60 to 70% of our seniors do pursue that. Last slide. So a little bit more about our integrated course. So that common first year, there's a 2-course design sequence with 4 integrated projects. And that design sequence, students learn some electrical engineering, some mechanical engineering, some chemical engineering, some systems engineering. So those projects have been created on purpose to make sure the students are doing all of those, partly to help them pick the concentration, but again, partly because we want that additional breadth of experience and training. We also have a seminar they take. We talk about skills. And by skills, I mean time management, organization, motivation, study skills. So we teach that. We talk about our values. We really work on building engineering identity, because that's important to retention. And then they're taking some of the general education courses, the math, science, and English, things that ABET requires and that are required at the university. So second, third, and fourth years, there's a common spine that's integrated of engineering courses. So there are courses that they all take. In addition to that, they take technical communications, a microeconomics course, and then there are concentration-specific engineering courses that they take, as well as general education courses. But again, we continue that integrated spine. Senior year, they all take a common capstone course. So again, all the concentrations together. We have industry-sponsored projects, and almost all those projects have students from multiple concentrations on them. The value of doing this is that we don't have to take a project and just put 4 mechanical engineers on it because nobody else can be on there. So we pick the teams based on the needs of the project. I've talked about the fact that we have a lot of focus on professionalism. So in our courses, we teach communication, teaming, project management, learning how to learn. That runs all 4 years along with the engineering courses. It's integrated in there. And again, our curriculum itself has additional breadth. Everybody takes circuits, for example. Everybody takes statics. We have engineering econ, engineering statistics. So our goal is to make sure students have additional breadth, more than they would get in just a traditional, say, mechanical engineering degree. And with that, I think I'm going to pass it back to Becky.
All right, thank you, everyone. So we have a summary slide here that we are really happy to share. I'm not going to talk through it because that's what we just did. But what I want to point out is that there are a lot of ways that we think about integrated engineering. And so these 6 areas are ones that that we would actually like you to see which ones of these might be most valuable for your own context as you perhaps think about integrated engineering as something that you could be involved with. So thinking about problem and project-based learning, this is one way we integrate. Thinking about community engagement and social impact, dealing with accreditation and quality when people aren't sure what we're really doing here. Thinking about access to engineering. One of the reasons that Iron Range Engineering and Twin Cities Engineering work with community colleges is because in the United States, that is an area where more people have access to learning and to starting an engineering degree. Then we think about industry and community partnerships, as well as how do we do assessment. So these are all areas we would be really happy to talk about. And so what we would like to do pretty quickly, just about 5 minutes, is have everyone go into breakout rooms and think of within the group a question that you have. So we know there's a lot of wisdom in the audience today. Some of you might have basic questions that other people could answer. If they can't, then those would be questions that would be good to bring up to us. Okay, so welcome back, everyone. If somebody from your group could put the question you came up with or questions either in the chat or the Q&A, that would be great. If you have no question, we would love to hear what you actually talked about during that time. And there is I think there was one question.
There was one question to start with about governance and institutional structures that enable integrated learning. I guess question of, can we say something about it? I think from my perspective, that was a big thing of, we had a dean who wanted to help invent some of these structures, but actually it was a gap. I mean, fortunately, we had a structure where money followed the student, which was handy because that's a mechanism you can leverage as to who's involved in teaching and who does things, and also a curriculum that's very well defined. Again, I know talking with US colleagues of, I can predict what modules the vast majority of my students will do in the first, second, and third year, and those structures mean I then have some control of it, which allows you to build some of this integration. And so, but I think as was opened with, the context and some of those very practical aspects often do very much dictate what you can and can't easily do.
And I will agree that we have a paper out from a while ago looking at the starting of innovative engineering programs, and a lot of it kind of boils down to, can you do something separate? Can you step away from existing structures? Do you have the freedom to do that, to really try different things? And that does require some top-down leadership, but it also really requires faculty coming at the ground level to make sure things happen. And so this is also then where context is really important. If you're an individual faculty member, you can think about what are things you could do in your courses where you have space. How can you integrate a socio-technical component of your class, even if it's just statics. So that is one part. But this is also an ongoing question, because sustainable change is an organizational challenge.
Yes, I would just say I echo the need for some sort of top-down or higher up leadership. That our dean, we had a new dean that came in, he was eager to sort of make his legacy, make his mark. And so we actually applied for a Revolutionizing Engineering Departments grant from the National Science Foundation in the US. And that didn't fund the department, but it gave us the freedom to think about doing something very different and to hire people that were synergistic with this vision. And that meant a new department, but still within the same school of engineering. And so that has pluses and minuses, because it means that we have to go through, say, the curriculum committee for the whole school. And just say innovation is not always looked upon favorably within that group. Even when I'm on that group, it doesn't necessarily, I think those structures are often set up to try to keep things along the status quo. So having our dean supporting us was really important. And then, this may sound silly, but we actually were able to move to a different building, which in some ways I think was really helpful. So I'd been at the university for a long time, but the rest of my department is much younger and much newer. And in some ways, it was unfortunate they didn't get to know the other people, but in other ways, it was very fortunate that they didn't have to interact with the other people, because we could kind of be together and have a chance to develop our own vision and identity. So I think there are a variety of different ways you can do it. Some places, the only engineering program, say like Jenna's, is this integrated approach. Whereas in mine, I have this integrated approach right next to a traditional electrical or mechanical. And I think that is more difficult. But it does mean our students don't have to choose until the fourth semester. So some of them may start out thinking very traditionally and come to USD because they think that's what they really want to be. And then as they learn about integrated, they may move over to us. One of my favorite quotes from a student is, I try to figure out how do I like the reluctance of other departments, is he said, well, I think sometimes people who uphold the status quo have a hard time appreciating innovation. So that's what I use all the time now, because it's not totally nasty, but it does sort of get at the heart of what's going on here.
Yeah, I will say quickly for us, we do have a School of Engineering, but we had to have support from the administration. So the provost or president actually had done some work ahead of time, because we needed some of the institutional general education requirements. We needed some changes there to be able to create a program. And so we had a lot of support there. And we had the freedom to kind of, I always say, one of the reasons I built the school here is I kind of had the freedom to do whatever I daggum well please, and money, which nobody ever says. So, that really gave us the freedom and ability to do that. But the thing, because at my previous university, we had a much larger and older institution, we did a lot of the same things. You have to have continued support over time, because if you have leaders who come along later who aren't supportive and don't believe it, they can pull back things and erode things. And so you really do have to be vigilant to try to keep that in place.
Yeah, definitely. There's another question here. Our book wanted to know about integration in large enrollment courses or at scale in larger curriculum, which I guess obviously one I could perhaps talk to. I mean, obviously at scale, you've got quite a lot of resources across that scale to draw on, but it does mean you probably put a lot of effort into some of the practical elements of things, in that and has thrown up some of the issues. The things that you could get away with in a class of 25 with a class of 1,000, you've just got to be far more organized and far more structured in some of the things you do. But we run project-based classes with a module of 1,000. It is possible. And I mean, in the end, we sort of started, we ended up at a point where we went, well, we've got 1,000 students. We used to break them down into 9 departments, each doing their own thing. But now we don't have the room to put them all 1,000. We need to break them down into something smaller. And actually, a lot of the framework came about, well, we do things with the individual departments. So actually, a lot of why we call the IEP a framework is because it's an agreed set of elements across the departments, but that each are somewhat handled are managed by the departments with some coordination. And that was our solution to a larger scale, because we just didn't have a place to do 1,000 students. We had they won't fit in our biggest lecture theatre, even if that was what we wanted to do. We certainly have no flat space to work on projects. So the scale scaling up is an issue, but you do get some economies of trying to work at that scale.
I think the rest of us are kind of lucky that that we have smaller programs. However, this is really a big deal, and this is where context again comes into play. So the idea of what do you have and what could you integrate to make it work in that space. And I know that starting a brand new program might give you the flexibility to say this is the type of experience we want our students to have. But in existing ongoing programs, then you might really be not able to do a full transformation. So what are the things that might be important to think about? Is it community engagement? Is it access, or is it autonomy? How could you give students more choice? Even in my regular classes, I might give students the choice to change the distribution of the homework in the grade versus the final exams. And I know that there's some infrastructure that wouldn't let that happen, but this is one way that I let students bring themselves into the class.
Yeah, one of the things that we found is that you can also do a lot with kits. So for example, our circuits class, every student has a kit and it's theirs. They take it home. And so we're able to do a lot of things that way. It's not terribly expensive. And it's something that they keep and continue to use. It builds on some of the kit material they had in an earlier class as well. So there are things that you can do without having a wholesale, renovating a classroom, for example. If you've got a place with tables and chairs that you could use, there's some things you can do that can bring in some of this sort of integrated type approach and project type approach.
There's another question here about what is the process to get there? How was the change process towards these curricula managed? And if you compare the planned curriculum with the desired curriculum and the attained curriculum, that's a good question.
I think that if you think that the end goal when you start, and that's the only way to measure success, you've possibly already failed. So we really have bought into the idea of a continuous improvement process. And we look at our context and we look at how students are changing. We look at how industry is changing, and we have set it up so that partly by allowing for more autonomy in the curriculum design, we can be more flexible and we can be more adaptable. So I had a student 12 years ago rewrite the curriculum for me so that it would look better on his transcript. And I thanked him. And about a couple of years after he graduated, he told me, "Oh, I did see what you were trying to do now. I think he appreciated it. He's one of our best alumni who gives back to the program and mentors project teams. But we never thought that our first attempt was the final attempt or necessarily the right thing. We knew we had to keep getting better."
I think if you think about any engineering endeavor, you do the best you can, you see how it goes, and then you iterate, because you're not going to get it right the first time. And so I think sometimes the fear is like, I don't know enough to try or to start. But I think sometimes you just have to take that first step, but then see how it goes and see what parts worked and what parts didn't. We wrote this revolutionizing engineering departments. The idea you can write a proposal for a revolution is actually ridiculous, right? If you can actually see all the way to the end of it, that's not a revolution, right? But you do the best you can. If you want to get the money from an institution like NSF, you have to write that and do what you can. But our classes, I would say, look somewhat like what we had envisioned them looking. But honestly, when I started doing, say, some of the electrical stuff, I really had very little idea where I was going. And some of it, I was like, but I'm not an expert. And then had someone be like, well, I don't think anyone else is doing it, so I think you have to just figure out how to do it. So I think you take a step in, but don't worry that you have to get it perfect the first time, because no one will get it perfect the first time.
Yeah.
I think there's a big thing about understanding. I mean, I picked up from a management course about this idea of understanding core and flex, that there are certain things that are very valuable to you that you must achieve, and other things that you're willing to compromise on. And, you know, I think in any negotiation, particularly when you're trying to transform an existing program, being able to be clear on what really are that is at the very heart of the transformation you're trying to see, and there's lots of other things around that you're willing to negotiate on how they're achieved, or but that you've got to be clear in your own head if you're leading something like this as to what must happen for you to be pleased that you've got there. And I think that for me was quite a useful tool, because everyone goes into a negotiation. You've got to leave a negotiation where someone has got something out of it, so having something to give is always a useful approach. We're getting a number of questions now. We're reaching time, I'm afraid.
But we are happy if you want to email us later to try to
Yes.
answer these questions, since we're pretty much out of time here.
Yes, and I'm going to take the last two slides, and on the last slide, you'll find all of our email addresses. So please copy those down if you'd like to ask specific questions. So, you know, sort of our core message is that, you know, there's not a single solution. As you see, we've each done some different things. There might be some common approaches, but we've also done some very different things to create an integrated engineering program. And sort of the key message or the underlying approach is, you know, trying to communicate or educate or provide students with transversal, transdisciplinary skills, simply because that mirrors what they're going to do in the real world much better than, you know, sort of silos that many programs sort of kind of focus on. And of course, the conversation should continue. So last slide there, Becky.
WS Powers, F1 Insight.
We do have a website. It's called integratedengineering.org. Our white paper is there. If you'd like to access some of the other materials and efforts that we have integrated it or engaged in, you can access those there. Again, you see all of our emails. We would be happy to answer any other questions that you have. And thank you for joining us today.